Hello everybody, welcome to another video of solving for exact differential equation or exact DE. Now let's get started. Here we have some examples that I have already solved, but I'm just gonna explain it to you guys how I've come up with the answer or what process I did to get the answer, okay? So here we have the first example, y squared minus 2xy plus 6x dx minus x squared minus 2xy plus 2 dy is equals to 0. So the first step in solving for exact d is to test its exactness. So we have this partial of n in terms of y is equal to the partial of n in terms of x. So let's solve for the partial of n in terms of y, and we're going to use this equation. So we're just going to derive this equation with respect to y, okay? So the derivative of y squared is 2y, and the derivative of negative 2xy will simply be negative 2x since y is equivalent to 1, so negative 2x times 1 is negative 2x. But the derivative of 6x is considered as 0 since there is no y variable. So it is considered as constant or it is considered as 0. Now let's solve for the partial of n in terms of x. Here we're going to use this equation. So we're going to derive this equation with respect to x. First, let's distribute this negative sign to inside this parenthesis. So this will be considered as negative x squared plus 2xy minus 2. Okay, remember that. So we're going to derive this with respect to x. So the derivative of negative x squared will be simply negative 2x. And the derivative of positive 2xy is simply 2y. Since x is equivalent to 1, so positive 2y times 1 will be 2y. But since 2 doesn't have any variable, doesn't have an x variable, it is considered as constant, so it is equivalent to 0. So, as you have observed, the partial of m in terms of y is the same as the partial of n in terms of x. This means that this equation is exact, so we can proceed to the next step. The second step in solving for exact DE is to find the partial of f in terms of x. So, this will be equivalent to m. So we're just going to integrate this. Okay, so since rm here will be this one. So we're just going to substitute that. So we will have now the f of x is equals to y squared minus 2xy plus 6x dx. Now we're just going to integrate this. So we will have the integration of f of x is equals to, since y squared is constant, this will be moved out of the integral sign. So we will have y squared, the integral of dx, minus 2y, the integral of x dx, plus 6, the integral of x dx. So now we will have the f is equals to, the integral of dx is simply x. So we have x times y squared is xy squared. Now, the integral of x by using the power rule, which is the let's say n raised to the power of n plus 1 over the n plus 1. Okay, so x, since the degree of x is 1, we will just add another 1. So this will become x squared over 1 plus 1 is 2. So we have negative 2y x squared over 2. Now, plus 6. Again, the derivative of x will be x squared over 2 plus, instead of arbitrary constant, the c, we will just use an unknown function. Let's use g of y, okay? But since this equation can be further simplified, we'll need to simplify this. So we will now have f is equals to x y squared minus x squared y. We just cancelled out the 2 from the from the numerator and the denominator. Then we have 3x squared, which is from 6 divided by 2, and the g of y. Now, let's proceed. We will now then derive this function, this potential function, in terms of y. Then we will equate this to the n equation, which is this one. Okay? So, the derivative of derivative of f in terms of y will be the derivative of xy squared is simply 2xy. And the derivative of negative x squared y is simply negative x squared. Since y is 1, then negative x squared times 1 is negative x squared. Then, this unknown function, we have that g of y will become g prime of y. Now, let's equate this to the n, which is this one. Just copy that. Then, we have negative x squared plus 2xy minus 2. As you can see, we have two terms that can be cancelled out, which is the positive 2xy and the negative x squared. So, all we have left is the g prime of y is equals to negative 2. So, to simply just get the g of y, we will integrate both sides by dy. So, we have the integration of g prime of y is equals to, since negative 2 is constant, we'll move that out of the integral sign. So, we have negative 2 integral of dy. So, we have now the g of y is equals to negative 2y plus the arbitrary constant c. Now, let's proceed to the last step. Just simply copy the function, this one, and then substitute that g of y to this one since we have now the value. So, we have the xy squared minus x squared y plus 3x squared minus 2y plus c. But since we have this equation f is equals to c, we will now have this last equation xy squared minus x squared y plus 3x squared minus 2y is equals to c. So there you have it, guys. This is our final answer. Okay? This is our final answer. Now, let's proceed to the second example. In our second example, we have 2x times 3x plus y minus y e raised to negative x squared dx plus x squared plus 3y squared plus e raised to the power of negative x squared dy is equals to 0. So we'll just simply distribute this to x so we won't have any confusion later. Now we will have a new set of equation which is 6x squared. 2x times 3x is 6x squared plus 2xy minus 2xy e raised to negative x squared dx plus x squared plus 3y squared plus e raised to negative x squared dy is equals to 0. So, let's proceed to the first step, which is to test for its exactness. Our partial m in terms of y here will be this equation. So, we're going to derive this equation with respect to y. Now, this will be, since 6x squared, the derivative of this one in terms of y will be 0. So, and for 2xy, this will be simply 2x. For negative 2xy e raised to negative x squared, this is simply negative 2xe raised to negative x squared. Okay? Is equals to the partial of n in terms of x, this one. So we're going to derive this in terms of x or with respect to x. So the derivative of x squared is simply 2x. Then since 3y squared doesn't have any x variable, or yes, it doesn't have any x variable, so its derivative is simply 0. Then, the derivative of e raised to negative x squared is simply negative 2xe raised to negative x squared. So, how? The derivative, when it comes to this problem, the derivative of this is simply the derivative of its exponent. So, the derivative of its exponent is negative 2x. So, copy that here, negative 2x. Then, copy this one. Okay, so here we have it. since we have the same result, so it is equal, therefore this equation is exact. Now let's proceed to step 2, finding the potential function in terms of x. Our m here will be this one, so copy that here. Now we're going to integrate this. The integral of f of x is equals to 6, the integral of x squared dx plus 2y, the integral of x dx minus 2y, integral of x e raised to negative x squared dx. So we have now the f is equals to 6. The derivative of x squared dx is simply x cubed over 3 plus 2y, derivative of x is x squared minus 2. And in this one, we're going to use the u substitution. So we're going to let u is equals to e raised to negative x squared. Then du is equals to negative 2x e raised to negative x squared dx. And we will now have negative du over 2 is equals to xe raised to negative x squared dx. So since this one and this one is the same, this one is considered as negative du over 2. Here, we're going to substitute that here. Now, we have f is equals to 2x cubed, since 6 divided by 3 is 2, so 2x cubed. Cancel out these 2. We will now have x squared y, and plus, since we can move, since 1/2, this one is considered as negative 1/2 du, we will move the 1/2, since it's constant, out. Okay, so this negative 1 will become positive, so it will become 2 over 2 y, the integral of du. Now, 2x cubed plus x squared y plus y, cancel this out. Then the derivative of du is simply u plus an unknown function. Now we have the equation 2x cubed plus x squared y plus y. Then return the true value of this u, which is e raised to negative x squared plus g of y. Now we'll proceed to the next step, which is the function of the partial of f in terms of y is equals to n. So we're just simply going to derive this equation in terms of y. Now we have x squared. We're going to derive this in terms of y. 2x cubed is the derivative of 2x cubed in terms of y is simply 0. Now x squared y, the derivative of this is simply x squared. Then the derivative of y e raised to negative x squared is simply e raised to negative x squared. And the derivative of g of y is g prime of y. Then is equal to n, which is this equation. So we'll just copy that. We have x squared minus 3y squared plus e raised to negative x squared. Now, so that we can get the g of y only, we're going to integrate both sides. Okay, I'm sorry, I forgot. Since in this equation it is clearly visible that we can cancel out two terms, which is the x squared and the e raised to negative x squared. So what is left is g prime of y is equals to 3y squared. Okay, so to simply get the g of y, we will integrate both sides by dy. So we have the integration of the g prime of y is equals to 3, the integral of y squared dy. So g of y is 3 times y cubed over 3 plus c, or simply gy is equals to y cubed plus c. Now for the last step, we're just going to copy this and substitute the gy with our with this one, since we have finally got the value for gy. So we have now the 2x cubed plus x squared y plus y e raised to negative x squared plus y squared plus c. But since in exact DE we have the function f is equals to c, we will now have this, we will move this c, or we will equate this equation to c. So we will now have 2x cubed plus x squared y plus y e raised to negative x squared plus y cubed is equal to c. So there you have it, guys. That's the final answer for our second example. So thank you for watching, and please watch our other videos as a support in our for our YouTube channel, guys. So thank you and God bless.